Hello everyone, very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. This is Sanjay Rathi, and guys, this is a network mesh and super mesh analysis. Okay, and that is the GATE 2024 YouTube plus app series mesh and super mesh analysis, guys. Now, this is my small introduction, and guys, after this session you have to join the session on what app? That is what BYJU'S exam prep app. So please first of all install the BYJU'S exam prep app, and after 20 minutes we will enter into the quiz on what our platform. And here I am going to give you the basic idea about the mesh and super mesh analysis in this session. And already we have discussed what we have discussed. We have discussed the KCL, KVL, nodal analysis, and we have solved number of questions, guys. So this is my small introduction. Myself Sanjay Rathi, and 22 years of teaching experience, and these are my ranks in engineering services exam in 2005 and 2008, and I have trained more than 1 lakh students for these competitive exams, guys. Now first of all, learn about the basics like what mesh analysis, super mesh analysis, nodal analysis, super nodal analysis, KCL, KVL, theorems, Thevenin's theorem, Norton's theorem. Once you will get the command over all these topics, then it will help you to understand the concepts of remaining part of network, as well as it will help you to understand the concepts of core subject like what analog, machine, power system and power electronics. Okay guys, now so what is this? Sir, right now I am going with the okay. I will give you the idea about that. Okay. So first of all, this is a GATE Ranker Monsoon series, free courses, most important topics from electrical, electronics and computer science. As you know, we have number of topics, guys, but out of these topics, mostly are redundant and some are very important topics. So we are going to take one series where we will give you the idea about the important topics, right? And not only we are going to give you the idea about the important topics, we will discuss those important topics. We are going to discuss important questions on those important topics. Okay, and that will help you for GATE preparation, guys. Okay, so this is the case. So very good evening, Kavita Bhagat, how are you? And Dave. Then this is the workshop tomorrow, 2nd July at 12 PM, guys. So please join this. Why? Because now we are having the 7 months. Are 7 months enough to get AIR under 100 in GATE examination? That is the big question. तो क्या मैं 7 महीने में GATE में टॉप कर सकता हूँ? Yes, कर सकते हैं आप, right? तो अगर आप इन एग्जाम्स में तैयारी करते हैं, that is the strategy given by the धीरज सरदाना sir and Abhinav Negi sir on 2nd of July at 12 PM. Please join that session now. So all in one, very good evening. Now this is a very simple mesh analysis. Within 10 minutes you will get the idea, and then from 7:30 onwards you can join my session on app. So guys, mesh analysis means what? Mesh, in a particular network we are having the loops. So mesh is a loop which does not contain any other loops within it, right? So this is a very basic definition of mesh. With the diagram I will explain this. Mesh analysis applies KVL to find the unknown currents. So we are using the Kirchhoff's voltage law. In previous class, I have given you the idea about the KVL. Then this is the mesh. For example, there are two meshes. This is visible to you. This is called mesh current I1 and that is called mesh current I2. And that is an independent loop. Inside this, there is no other loop. This is a loop. But suppose you are considering, is it a mesh? No. Because inside this is also a loop, but it is not a mesh, because it is considered two loops inside that. But when we are considering this one, inside this there is no other loop, inside this there is no other loop, so that is there are two meshes. And then we are assuming two currents, I1 and I2. These are called mesh current. These are not the branch current. The branch current is I1 here. What is the branch current? I3. And what is the I3? I1 minus I2. What is the I3? I1 minus I2, that is the mesh current. Okay, so that is in this way we can solve this question. So this is a mesh analysis, and we are going to apply the KVL here, Kirchhoff's voltage law. Okay, so how we can write the KVL? First of all, you have to assume the current, that this is the I1 and I2. Then you can write the KVL like this. This is the mesh current, let this is the minus V1 plus this I1 into R1 plus what is the current in this branch? In this branch, in downward direction, I1 minus I2. This is in upward direction, this is in downward direction. So it will become I1 minus I2 into R3, because this resistor is what? R3. Now you can arrange this is equal to 0. So I1 R1 plus R2 minus I2 into R3 is equal to V1, and that is the first equation. Now second equation, that is called KVL. In this loop, I2 is the mesh current, so I2 into R2 plus V2, this is the plus minus plus V2, and what is the current in opposite direction? In upward direction, the current is I2 minus I1, because that is the mesh current, so that is the current I2 minus I1 into R3. I2 minus I1 into R3 is equal to 0. Arrange this, you will get I2 R2 plus R3 minus I1 R3 is equal to V2 minus V2 is equal to minus V2. Be careful about that sign, otherwise you are going to get the wrong answer. Once you will get the equation, there are two equations, two unknowns, I1 and I2. That's why we can directly apply what? This is first of all, remove this, because this is a branch current. That is not needed here. Okay, try to understand. This is the branch current. I am talking about the mesh current. These are the branch currents. Right, these are the mesh current I1 and I2. Okay, what is asked here? Sir, we can use the KCL here. No, you can use the KCL also, but I am talking about what? Mesh current. To find the mesh currents I1 and I2, we are using what? KVL. And suppose we are using the KCL at this point, that means we are going to find what? Nodal voltage. Nodal voltage, for example VB. Then we are applying the KCL, VB minus this upon R1, VB minus 0 by R3, VB minus V2 upon R2. And in this way we can find the VB, that is called node voltage. Okay, so that's why we are applying the KVL here, because it is a mesh analysis. So there are two mesh. So what is the basic definition? Mesh is a loop which does not contain any other loops within it. So that is the mesh, and we are applying the KVL. Now another definition: assign mesh currents I1, I2, I3, IN to the n meshes. Apply the KVL to each of the n mesh and use Ohm's law to express the voltage in terms of the mesh currents. Solve the resulting and simultaneous equation to get the mesh currents. Suppose there are three unknowns, then we are going to get the three equations. Two unknowns, then two equations, and then we can find it. This is the case. Then already I have given super mesh means what? Where is the super mesh we are going to apply? Suppose there are two loops, and within two loops we are having the current source. For example, watch this diagram, it is visible to you everyone. This is the one loop, one mesh, there is another mesh, these are independent loops. Inside this no other loops. This is the mesh, this is the mesh, but we are having a current source in between. When we are having the current source, then we have to apply the super mesh analysis. So what is the super mesh analysis? Watch this. Super mesh analysis means for example, this is the current source is given. Let this is the diagram. Okay. Then if the current source is given, so you can assume the two mesh currents. Let this is I1, this is I2. Now because of this current source we can't write the KVL in this loop, because we have no idea about the voltage across this I. Then what we are doing, What is the current in upward direction? The current in upward direction is I2 minus I1. We are getting the first equation, I2 minus I1 is equal to what? I2 minus I1 is equal to what? I means what? 2, right? So it is a constant current. It may be 5 ampere, 6 ampere or so on. So we are writing the first equation, I2 minus I1 is equal to I. These are the mesh currents. Now consider this mesh only outside. Remove this and apply here. So this is the V1, this is R1, this is R3, this is R4 and this is V2. What is the current here? I1. But what is the current here? I2. And now write down the KVL. So simultaneously we are applying KVL in this loop. This is called super mesh. When we are applying the KVL is valid for any closed loop. So just we are giving the KVL. So we are writing minus V1 plus I1 into R1 plus I2 into R3 plus R4, because these two resistors are in series, plus V2 is equal to 0. And then you will get the second equation, I1 R1 plus I2 R3 plus R4 is equal to V1 minus V2. Again we are reading the two equations, there are two unknowns, then we can solve it. Sir, how can you be in okay, Dev, I am join my Telegram channel, right? Touch with all subjects. You are talking about my plan, how I have cleared engineering services and so on. What you want to say? Here, try to understand. Yesterday, day before yesterday, I think, yes, 2 or 3 days back, in Tuesday, Wednesday, we have solved all the questions of what engineering services examination. Initially, we have solved all the questions of what GATE paper 2023. So just to practice, try to solve the questions from previous year question paper. Okay. And take it just like a challenge, because sometimes we are not having the solution. Again, we are trying to solve all this. Okay. So questions banao, try to solve the questions and always use what? Copy, pen and calculator. Normally we are watching the solution on screen. We are not solving, and that will not work for you. If anyone, if you want to get the command over the subject, then try to solve the questions on what pages. Use your copy, pen, calculator. Try to make short notes, because these days we are simply downloading the PDF and we are taking the printout, and just for in revision we are using. BJT is the problem. Don't worry. BJT I will give you the, first of all go through my notes and then 1 or 2 times, and then once you will get the basic idea about the BJT will become very easy for you. Okay. So that is the equation to super mesh analysis, guys. So always remember, if there is a current source, then we have to apply the super mesh analysis. Now, this is the mesh analysis. So already I have given, it is based on systematic application of Kirchhoff's voltage law, and KVL is based on law of conservation of energy. So that is the case, first case. Second, it is also known as loop analysis or the mesh current method. It is used to find the unknown currents through any branch. Once you are going to find the I1, I2, then we can find the current through any branch. We can find the voltage across any element. That is the use of this mesh currents. Okay. Now that is the, for example, this is the diagram. So how many mesh current? Tell me. How many mesh currents are possible? This is I1, because this is a independent loop. It does not contain any other loop, right? Second, I2. Third, I3. We can assume the 3 mesh current, I1, I2 and I3. Right? This is the I1, I2 and I3. 3. And then you can write a KVL. So always remember, what is the current in downward direction? I1 minus I2. So you can write minus V plus I1 R1 plus I1 minus I2 into R2, because it is common, is equal to what? 0. So that is called KVL. And you can arrange I1 R1 plus R2 minus I2 R2 is equal to what? V. That is the first equation. That is the first equation here. Okay. Second equation, similarly, you can write I2 into R3 plus I2 minus I3. What is the downward current? I2 minus I3. And we are moving in the direction of what? I2. So I2 into R3 plus I2 minus I3 into R4 plus what is the current in upward direction? I2 minus I1. So I2 minus I1 into R2. So this is the I2 minus I1 into R2, this equation. Arrange this equation. So guys, we can directly write, we can save our time during competitive exams. How? That is called inspection method. In inspection method, what we are doing, suppose there are two resistors R1 and R2. And what is the mesh current here? I1. So we are directly writing I1, R1 plus R2. And what about the direction of the I2? It is in opposite direction. Then we are writing I2 into R2, which is common resistor R2. And when the current enter into the minus terminal, means it will deliver the energy, that is equal to what? V. It will consume the energy, it will deliver the energy, both, right, and so on. So when the current enter into the negative terminal, leave the positive terminal, that voltage will be positive on right hand side. So that is the inspection method. Similarly, watch this loop. How many resistor? R2, R3, R4. What is the mesh current? I2. You can directly write R2 plus R3 plus R4. Now what is the direction of I1? Opposite. I2 is moving upward, it is moving downward. Then you can write I1 R2 because R2 is the common resistor. And here what is the direction of the I3? I2 is moving downward, I3 is moving upward in this branch. You will write minus I3 into R4. And any battery? No battery. 0. If the current enter through the positive terminal of the battery, it will be negative on the right hand side. If it enter into the negative terminal, it will be positive. So that is the case. So please watch this equation. To direct inspection method, you can directly write. You will get this equation directly. No need to write this equation. No need to write this. Similarly, at the end, I3, R4 plus R5 plus R6. R4 plus R5 plus R6 minus, what is the I2? It is in opposite direction of I3, and which is the common resistor R4. I2 R4 with minus sign is equal to 0 because there is no battery. So we are saving our time. There are 3 unknowns, 3 equations. You have to solve the 3 equations and then you can give the answer, guys. So that is about the mesh analysis. Okay. So bus equation, but just after this we will solve the questions on what app. So please stay tuned with me. And that is the example of what super mesh analysis, guys. Watch this. This is the question of super mesh analysis. First of all, in this loop, you can assume I1, I2 and I3. But we are having a current source. Then we have to apply the super mesh here in this loop. 1 KVL in this loop, 1 KVL in this. Directly, we can apply the inspection method. So it will become I1 R1 plus R2 minus I2 into R2 because it is in opposite direction. And current enter into the minus terminal, and that's why you can write the V. This is the first equation. Second, you have to move through this path. Plus minus, plus minus, plus minus, plus minus. Then it will become I2 into R3 plus I3 into R5 plus R6 plus I2 minus I1 into R2. I2 minus I1 into R2, and loop KVL is completed. This is R6. This is called super mesh equation 0. This is equation number 2. 3 unknowns, 2 equations. Then what about the third equation? This is the current source. And what is the direction? Downward direction. So what is the current in downward direction in this branch? This is the I2, this is the I3. So downward direction, it will become I2 minus I3. And that's why the third equation will become I2 minus I3 is equal to I. I2 minus I1 is equal to I2 minus I3 is equal to I. This is the third equation. So what we are applying here? Super mesh analysis, right? So there are three unknowns, three equations, and in this way we can solve the question. So hope so. Any doubt regarding this? Because within 2 minutes you can join me on app where we will solve questions on what mesh analysis, super mesh. That is the quiz. You have to give the answer. I will provide it. I am going to provide you the solution, guys. I am going to provide you the solution here. Okay. These are the basic idea about the mesh and super mesh analysis. Now, guys, this is the link of the session is given in the description and chat. Attend the quiz now. First of all, install BYJU'S exam prep app. Okay, and then you can quickly. This will continue. So this is the session now. Continue on BEP then. Okay then. So I am waiting for you guys. Please join the session now. We will solve around 8 questions on mesh and super mesh analysis, and definitely you will get the command over this. Okay. Okay then. Join quickly.